Now, a linear equation in two variables has one of these two forms. AY x plus by equals c, or A equals sx plus b, where x and y are the coordinate variables, and a, b, c, s, and b are constants. Written either way, they graph as straight lines in the plane. Y equals constant, for example, graphs as a horizontal line. X equals constant, graphs as a vertical line. Now you can test if a point is on a line by substituting into the equation. For example, is 2 by 3 on the line, y equals 7x plus 3? Well, we plug it in. 2 for x, 3 for y. So the left side will be 3. The right side will be 7 times 2 plus 3, which is 17, so no, and it's not equal to the left. So 2 by 3 is not on the line with equation 7x plus 3. Well, how about the point 2 by 17? Is it on that line? Well, left side is 17. Right side, you plug in a 2. Hit 7 times 2 plus 3. That is 17, so yes, they are equal. I should say this there. Okay, hold on. Another correction. To page 2. That equals the left side. So these equal, and so therefore this point, 2 by 17, is on the line with this equation. I sometimes, here I abbreviate by saying not on the line with this equation, but on the line and then say the equation. All right. Here we have a line with equation 2x plus 3y equals 16. Is 5 by 1 on that line? Is 2 by 4 on that line? Okay, here we go. Left side, I'll plug in 5 for x, 1 for y. 2 times 5 plus 3 times 1, that's 10 plus 3, 10 plus 3, not 13. Ah, my goodness, loaded with errors. All right, but anyway, that's 13, which is not 16, so no, it doesn't work. 5 by 1 is not on that line. Whereas, is 2 by 4 on that line? Well, substitute 2 for x, 4 for y, 2 times 2 plus 3 times 4, 4 plus 12 equals 16. Yes, that equals the right side. So the 2 by 4 is on the line with this equation. Now, this is okay, suppose we have it in the form y equals sx plus b. This is actually pretty easy to do. You can create a table. You take various values of x from this, calculate various values of y, and plot the points, and they should line up. Yeah, I mean, usually it's enough just to do 2 points, because 2 points determine a line. But let's do a few more, just in case. Here the equation is 3x minus 2. And let's try various values of x. You have a certain amount of freedom for that. Here we have negative 1, 0, 1, and 2. Plug in negative 1 in for x, you get negative 5 for y. Plug in 0 for x, this term cancels, and we're left with the constant term, negative 2. Plug in 1 in for x, you get 3 minus 2 is 1. Plug in 2 in for x, 3 times 3 is 6, 6 minus 2 is 4, 2 by 4. So here is point negative 1 by negative 5, here's 0 by negative 2, here's 1 by 1, here's 2 by 4, and they graph as a straight line. Now here we have this other form of the line, ax plus by equals c. Later we'll see that this form is called the slope-intercept form. B is the intercept where it meets the y-axis. The slope is a measure of the steepness of the line. This is called a general form because it also includes vertical lines, which you can't write in this form because you'd have to have an infinite slope. Anyhow, ax plus by equals c, solved by intercepts. Well, it's a line sloped, and it'll meet the y-axis and the x-axis somewhere. Where it meets the x-axis, that's the x-intercept, and everywhere on the x-axis, y equals 0. So to find the x-intercept, set y equal to 0 and find x from that. This is the y-axis on which x equals 0. So set x equals 0, solve for y, and get the y-intercept. And given 2 points on 2 intercepts, Two intercepts, 2 points, you draw the line between them, and that gets you the graph. So find the x and y intercepts, plot those points, and draw the line between them. For example, 2x plus 3y equals 6. All right, first let's set x equal to 0. Then you get twice 0 plus 3y equals 6, 3y equals 6, y equals 2. So you have the point 0 by 2 plotted here. We set y equals 0, 0 here, you get 2x plus 3 times 0 equals 6, so 2x equals 6, so x equals 3. So the other intercept is 3 by 0. The x-intercept graphed here. 0 by 2, 3 by 0, plot them, draw the line between them. There's your graph. More examples then. Now here we have 2 points, 1/6 by 11, and negative 2.1 by 0.6. Are these points on the line with the equation y minus 6x equals 10? Okay, let's start with this, 1/6 by 11. You plug in 1/6 for x and 11 for y. And the left side equals 11 minus 6 times 1/6. That's 11 minus 10 equal 1 equals 10, which equals the right side. So yes, point A is on the line. Negative 2.1 by negative 0.6, let's check that. All right, y is negative 0.6, so negative 6 minus 6 times x, which is negative 2.1. Negative 0.6 minus 6 times negative 2.1, after a bit of calculation, that's 12, which does not equal the right side, so no. Point A is on the line, point B is not. Now here we have an equation. They ask an equation. The book has to fill in the table and graph the line. Y equals a negative third x minus 1. They give you values, we test values at negative 3, 0, and 3. What are the values? Plug in negative 3 in for x here, and after a bit of calculation, you get 0. Plug in 0 for x in here, y becomes negative 1. Plug in 3 in for x here, y becomes negative 2. So we plot negative 3 by 0 here, plot 0 by negative 1 here, plot 3 by negative 2 here. And there's your line. Now here we graph 3x plus 4y equals 12. All right. All right, let's start by setting x equal to 0. Get 3 times 0 plus 4 times y equals 12. So 4y equals 12, so y equals 3. So there's the point 0 by 3, and we plot it here. We can set y equal to 0, and we get 3x plus 4 times 0 equals 12 here. That's 3x equals 12, so x is 4. So you have the point 4 by 0. So 0 by 3 and 4 by 0 are on the line. Draw the line between them, and there's your graph. Here's graph 5x minus 4y equals 13. Same routine. We set x equal to 0. Into here, we get an equation, y equals negative 13/4. So 0 by negative 3.25, this point here. Set y equal to 0, you get 5x minus 4 times 0 is 13. After a bit of algebra, x equals 13/5. So we get 2.6 by 0 plotted here. And we draw the line, and there's your equation, and there's your graph. Well, all right, these are all pretty much the same thing, basically. X plus 2y equals negative 2. Setting x equal to 0 gets you y equal negative 1, so we plot 0 by negative 1. Setting y equals 0 will get you x equals negative 2. So negative 2 by 0, plot this line. This one, however, has a weakness. 4x minus 5y equals 0. If you set x equals 0, you get y equals 0. If you set y equals 0, you get x equals 0. So the two intercepts are the same, and that's only 1 point. It's not enough to graph. So let's instead just solve for y and make a table. If 4x minus 5y is 0, then 4x equals 5y, and dividing by 5, y equals 4/5 x. So, okay, we can try various values of x, negative 5, 0, and 5. When x is negative 5, plugging in, you get see y is negative 4. When x is 0, plugging in, you get y equals 0. When x is 5, plugging in, you get y is 4. So here plot here is -5 by -4. Then we plot 0 by 0 here. Then we plot 5 by 4 here, and there's your line. Okay.